The F-35B Lightning II represents a leap in military aviation, a stealth fighter that defies the traditional constraints of runways. Much of its mystique lies in its ability to operate from cramped amphibious decks and austere forward-deployed airfields. This is enabled by short takeoff and vertical landing, STOVL. Many know the dramatic vertical landing, but fewer understand a critical takeoff configuration, Mode 4. Mode 4 unlocks combat potential from limited spaces, blending forward momentum with vertical thrust in a carefully balanced aerial ballet you will almost never see at a public air show. Mode 4 is not a simple switch, it is a computer-aided flight regime that lets the F-35B take off with more fuel and weapons than a pure vertical lift, a compromise between long runway conventional fighters and the payload limits of pure vertical takeoff. Understanding this mode reveals the F-35B's strategic value. Projecting power from the sea with air support and strike when air bases aren't available. We'll demystify Mode 4, mechanics, operational benefits, and its role in naval and expeditionary warfare. Before dissecting Mode 4, we must understand STOVL, short takeoff and vertical landing. It describes aircraft that launch from very short runways and land vertically without forward motion. In contrast, conventional aircraft need thousands of feet to get airborne and to slow down. STOVL frees jets from big, vulnerable bases. Its advantage is operational flexibility. It enables deployment from smaller ships, America-class, Wasp-class, and Queen Elizabeth-class carriers, ships without catapults or arresting gear. On land, damaged runways, highways, and small forward bases reduce response time and complicate enemy targeting. Achieving STOVL is hard. Redirect thrust from horizontal to vertical. Solutions include rotating nozzles, auxiliary lift jets, or the F-35B's shaft-driven lift fan. Powered lift adds weight, stress, and burns fuel fast, so it's used judiciously. Different phases and missions call for different STOVL applications. Mode 4 is a specific STOVL configuration within the F-35B system, designed exclusively for short takeoff. Think of it as a hybrid mode, combining conventional wing lift with powered vertical lift. The aircraft performs a short ground roll, letting the wings generate lift, as the propulsion system adds vertical push to get airborne sooner. In essence, it's the heavy lift short takeoff setting. The goal: maximize takeoff weight from limited runway. Conventional uses long runways and is most efficient. Vertical needs none but limits payload. Mode 4 sits in the middle, needs a short roll, carries far more than vertical. Once airborne and fast enough, the pilot converts back to conventional flight. Doors close, nozzle aft, and it's a sleek supersonic fighter. The F-35B's Mode 4 takeoff is rooted in the Pratt & Whitney F135PW600. More than thrust, it's an integrated power system. Key pieces: the 3-bearing swivel module and the shaft-driven lift fan. In Mode 4 they work in harmony, orchestrated by flight control computers. When the roll starts, several things happen at once. The main shaft engages a clutch, transferring power to the lift fan, which spins up, Rolls-Royce engineered, generating over 20,000 pounds of cool vertical thrust. The 3BSM swivels down, typically 45 to 60 degrees, adding rear vertical lift. Balanced precisely with fan lift up front, the system manages center of gravity and stability. Roll posts bleed air to stabilize side to side. Computers modulate fan, nozzle, and roll posts as wing lift grows until total lift exceeds weight, and it flies. For the pilot, Mode 4 demands deep trust in automation. The pilot doesn't micromanage fan, nozzle, or roll posts. They set STOVL, define the takeoff intent, while computers calculate parameters: weight, temperature, humidity, and wind. Line up on the marks. Advance throttle to the designated setting, and the aircraft orchestrates fan engagement, nozzle positioning, and roll post arming. The pilot maintains directional control and monitors airspeed, altitude, and rotation cues. At Q speed, a small rotation raises the nose. Flight controls smooth the liftoff. No over-rotation, no tail sink. The aircraft feels buoyant, climbing steeper than a conventional jet. Next, accelerate and command conversion on the throttle switch. Computers retract STOVL hardware and convert to full wing-borne flight within seconds. A brief, critical phase, fast, precise, and executed with system discipline. The ultimate reason for Mode 4's existence is payload. Fuel determines range and time on station, with internal and external options, plus bombs, missiles, and sensor pods for mission effects. Without combat load, a fighter's utility shrinks. Mode 4 enables a much heavier takeoff from a short deck than vertical. Like a running start, the short roll lets wings assist lift. The result, thousands of pounds more permissible takeoff weight. Extra fuel, more weapons, or both. For strike it can mean two 2,000-pounders instead of 1,000s. For air-to-air, full internal missiles plus endurance. Without Mode 4, you'd need immediate tanking or accept tiny mission radii. Mode 4 is a force multiplier, turning amphibious ships into potent light carriers. It enables meaningful long-range missions from the sea. Mode 4's primary stage is on amphibious assault ships and light carriers, used by the United Kingdom, Italy, and Japan among others. These decks lack catapults. Mode 4 is central to their air power. It turns troop carriers into fixed-wing strike platforms. During amphibious operations, jets launch close to the fight. Loaded with precision bombs and air-to-air missiles, they deliver close air support, strike air defenses, and establish air superiority. Full mission loads mean longer time on station and higher sortie tempo. On land, damaged bases can still launch F-35Bs via Mode 4. This underpins distributed operations. Many resilient nodes. Prefabricated matting enables FARPs for refuel, rearm, and relaunch. Even reinforced roads become functional launch pads. Maritime and terrestrial, Mode 4 gives commanders options, resilience, and surprise power projection. Powered lift consumes more fuel than conventional takeoff, far less than pure vertical, but still a factor planners must account for. Downward vectored exhaust stresses decks and demands heat-resistant coatings. Operations require cleared zones and secured equipment for safety. Lift fan, clutch, drive shaft, and nozzle add complexity and weight. STOVL stresses components and can increase maintenance costs. Robust logistics keep availability high far from major bases. Pilots train extensively for the critical role to liftoff transition and contingencies. Reliability hinges on software integrity and hardware testing. Risks are mitigated through engineering, training, and strict procedures. Yet some risk remains when pushing aerodynamic boundaries. Mode 4's benefits are judged worth the costs. In conclusion, the F-35B's Mode 4 is no mere spectacle, it is a core enabler of modern expeditionary warfare. By blending a short forward roll with powerful vertical thrust, it launches fully loaded from confined decks and short, rough runways. It bridges payload-limited vertical flight and runway-hungry conventional flight. That hybrid translates into real combat effectiveness. It turns amphibious ships into light carriers and multiplies viable land bases. Commanders project fifth-generation power in ways that confound enemy plans. Yes, there are trade-offs: fuel, complexity, stress, managed by engineering and training. The short rolling takeoff you rarely see may be the more important feat. It unlocks F-35B potential almost anywhere, defining expeditionary air power for decades.